In this video, we will be determining domain and range from the graph of a function. We will jump right to an example. Determine the domain and range of the graph of the function below. You can see we have a solid dot on the right, or a closed dot at 2, 4, and an open dot or a hollow dot at -3, -6. Let's visualize the shadow of the graph on the x-axis. The domain stretches from -3 to 2, not including -3, but including 2. We can write this as the set of x's such that x is greater than -3 and x is less than or equal to 2, where x is a real number. Or in interval notation as the half-open interval from -3 to 2. An open bracket next to the -3 and a closed bracket next to the 2. Let's visualize the shadow of the graph on the y-axis. This stretches from -6 to 4, not including -6, but including 4. In set notation, this is the set of y's such that y is greater than -6, and y is less than or equal to 4, where y is a real number. In interval notation, this is y is an element of the interval from -6 to 4, with an open bracket near the -6 and a closed bracket near the 4. And we're done. Here's a second example. Determine the domain and range of the graph of the function below. This is a straight line, continuous graph. There are no bounds. All we see is 2 arrows on the ends. So the shadow of the graph on the x-axis is from the left arrow to the right arrow. We can write this as a set of x's such that x is greater than -infinity and x is less than +infinity, where x is a real number. We can also write this as x such that x is an element of the real numbers. In interval notation, this is x is an element of the interval from -infinity to infinity. This is a fully open interval, and must be. Let's look at the shadow of the graph on the y-axis, with an arrow going up and an arrow going down. The range is y such that y is greater than -infinity and y is less than +infinity, where y is a real number. Or just y such that y is an element of the real numbers, or all real numbers. In interval notation, this is y is an element of the fully open interval from -infinity to infinity. And we're done. Here's a third example. Do the same thing. Determine domain and range of the graph of the function below. This is a semicircular figure. Let's look at the shadow of the graph on the x-axis. It stretches from -4 to 4, not including the -4, but including the 4. So now we can write this in set notation as the set of x's such that x is greater than -4 and x is less than or equal to 4, where x is a real number. In interval notation, we can write this as the half-open interval from -4 to 4 with a round bracket around the -4 and a square or closed bracket around the 4. To find the range, let's look at the shadow of the graph on the y-axis. At first glance, you may think it stretches from 0 to 4, not including the 0, but the solid dot dominates, and the y values stretch from 0 to 4 on the y-axis. We can write this as a set of y's such that y is greater than or equal to 0, and y is less than or equal to 4, where y is a real number. In interval notation, we can write this as the fully closed interval from 0 to 4. Notice the square brackets. Here's our fourth graph. Once again, determine the domain and range of the function below. The shadow of the graph in the x-axis stretches from 3 to infinity, not including the 3. We can write this as a set of x's such that x is strictly greater than 3, where x is a real number. In interval notation, this is the fully open interval from 3 to infinity. Notice the round brackets. Let's look at the shadow of the graph in the y-axis. The y values stretch from 0 to infinity, not including the 0. So in set notation, this is y such that y is strictly greater than 0, where y is a real number, because all your y numbers are strictly greater than 0. In interval notation, this is the fully open interval from 0 to infinity. Here's a fifth graph. Determine the domain and range of the graph of the function below. Let's look at the shadow of the graph in the x-axis. the graph stretches from 6 to negative infinity to the left. So in set notation, this is written as x such that x is strictly less than 6, where x is a real number. In interval notation, this is the fully open interval from negative infinity to 6. Let's look at the shadow of the graph in the y-axis. The low point on the graph happens at 1, and the arrow points to infinity. So the range can be written as y such that y is greater than or equal to 1, where y is a real number, because the 1 is included. This can be written as y is an element of the half open interval from 1 to infinity. Notice the square bracket around the 1, and we always put a round bracket around infinity. Here's some practice. Determine the domain and range of the graph of the function below, using lists, words, set notation, and interval notation where possible. You may wish to hit pause here and try this on your own. Let's organize this in a table. This is a discrete graph. Notice that the x numbers stretch from -4 all the way to 0. So we can say all the integers greater than or equal to -4 and less than or equal to 0. We can now list them as x equals -4, -3, -2, -1, and 0. In set notation, this can be written as x such that x is greater than -4 and x is less than or equal to 0, where x is an integer. Interval notation is not applicable for discrete data. Let's do the range. The y numbers stretch from a low of -1, and they go up in increments to 3. So the range is all integers greater than or equal to -1 and less than or equal to 3. We can list them as y equals -1, 0, 1, 2, and 3, all the y coordinates of the points. In set notation, we can write this as y such that y is greater than or equal to -1, and y is less than or equal to 3, where y belongs to the set of integers. And once again, interval notation is not applicable. Please proceed to the next video in this lesson, and thank you for viewing.